Good evening, students. Today I am going to teach you the concept of acceleration. Acceleration. Got? In simple words, the meaning of acceleration is what? To speed up or to speed down. In simple layman's understanding. Means if, for a layman's understanding, if the speed of an object changes with time, then we can say the object is accelerating. Got? For a physics student, we can say if the velocity of the object changes, then we can say that concept is called your acceleration. Got? Means it is nothing but the rate of change of velocity is called your acceleration. So it's a new concept to you. Try to understand it. Acceleration is what? The rate of change of velocity. The rate of change of velocity is called your acceleration. It means if the velocity of an object changes with time, then we can say the object has some acceleration. So this leads to two kind of definition, just like your velocity, means average value and instantaneous value. So we can have here, like, we can have average acceleration. Average acceleration is what? Simply v2 minus v1 by t2 minus t1. So what is these quantities? What is v2 and what is v1? What is t2 and what is t1? v1 is, we can say, is the velocity at time t1, and v2 is the velocity at time t2. Got? So means change in velocity with the divided by time span is called your average acceleration. Now this quantity can be termed as your delta v, del v by del t. And the instantaneous acceleration is what? It is simply if this time span tends to 0, it means limit delta t tends to 0, del v by del t, which is nothing but dv by dt, is called an instantaneous acceleration. It means suppose one object is accelerating, means its velocity is changing. So at a particular moment, what is the rate of change of velocity? That is called your instantaneous acceleration. Got? It means if you plot a graph between simply velocity and time, and you found the graph will be like this. Suppose at this instant you are asked to calculate the instantaneous acceleration, the velocity time graph, at exactly at this point you draw a tangent to that point. That tangent will make some angle theta with your time axis, then find out tan theta, that will give you your instantaneous acceleration. So which is given by dv by dt. So let us elaborate what is the acceleration. Already we have written the rate of change of velocity. If the velocity changes, then the object must have some acceleration. So let us understand the instances where the velocity changes. We know velocity is a vector quantity. A vector quantity is a quantity having both magnitude as well as direction, and they obey vector laws. Got? Vector laws of additions. Since it is a vector quantity, it must have some direction. So try to understand, there are three instances where the velocity of an object can change. Suppose an object is moving in a straight path, in a straight line path, the speed of the particle can increase, can decrease. Then we can say the velocity is changing. Means if the speed changes, means automatically the velocity will change. Clear? If the speed of the object increases, though the object is moving in a straight line path, then we can say the object is accelerating. Because if the speed changes, then the velocity changes, and the velocity changes means there must be some acceleration. Suppose the object is moving at a constant speed in a straight line path. It's just moving along the x-axis and it's slightly taking a right turn in that straight path. So in that case, the speed is constant. Suppose the object speed is 30 meters per second. It is moving straight earlier, but at this point it is taking a turn towards the right. So in that case, though the speed is constant, as the direction is changing, so the velocity of the particle is changing, of the object is changing. In that case, we can say the object is also has some acceleration. And the third instance, suppose the object is moving in a straight path where both the direction as well as the speed changes. Speed changes means it may increase, it may decrease. Try to understand in that case. Speed, your velocity changes means speed may increase, may decrease. Direction and speed both changes. In that case also the object has some acceleration. Simple example, the object is moving with 30, it's increasing its speed at the same time taking a turn, or it is applying a brake and taking a turn. So in that case we can say the object has some acceleration. Got? So to have acceleration, the velocity must change. If the velocity is not changing with time, then the acceleration of the object is 0. Clear? So that is the important part of your acceleration. So let me summarize here. If the speed changes, object has some acceleration. If the object's direction of motion changes, then object has some acceleration. If both speed and direction changes, then the object must have some acceleration. Got it? So this is the basic difference between instantaneous acceleration and average acceleration. Now we can solve some questions related to this acceleration as we have solved in the case of you to find out the velocity of an object, average velocity and instantaneous velocity. Got it? So now students, let us understand the concept of positive acceleration and negative acceleration. Acceleration is said to be positive, try to understand, if the speed of the particle increases with time, then we can say acceleration is a positive value. And if the speed of the particle is decreasing, means acceleration has a negative value. See, this can be restricted in some other way. If you can say if velocity and acceleration they are in the same direction, then acceleration is said to be positive. If velocity and acceleration they are directed in the same way, this can only be possible if speed of a particle is increasing. And if the speed of a particle is decreasing, then velocity and acceleration they are oppositely directed. So in that case, acceleration will turn to be negative. One simple example, suppose if you throw a ball upward. If you throw a ball upward, in that case, the velocity at which you are throwing up, it is maximum at your hand at the time of being released. At certain instant of time, it is at rest, means initial the velocity is more or the speed of the particle is more, and at the topmost point the speed of the particle is 0. So gradually it is decreasing, means as the speed is decreasing, so in that case the velocity is upward and the acceleration is downward, that is acceleration due to gravity. So in that case you can take acceleration to be negative. In a simple case, suppose you are dropping an object. Suppose there is an object, you just simply dropping that object. So if you drop it, you see at the time of dropping the speed of the particle is 0, when you drop it, gradually its speed will increase. So this is a situation where the speed increases. So in that sense, you see gravity is downward, also the velocity is downward. So in that case, acceleration can be taken to be your negative. This is a simple example I have given. So this concept you can apply in some other instances. So basing on this idea, let me solve a question related to your acceleration. How to find acceleration here? Try to understand. Acceleration, what I have said, it is the value of instantaneous acceleration is nothing but your dv by dt. Now see here, we know v is equal to dx by dt, means velocity is rate of change of displacement and acceleration is rate of change of velocity. So we can write in this case d by dt of, instead of v I can write dx by dt. So which implies in this case acceleration is how much? It is d square x by dt square. All of you try to understand, this is a symbol of your second derivative or double derivative of your displacement gives you the acceleration. Means if you find a derivative of x twice with respect to time, then you are going to get the value of your acceleration. So second derivative of displacement will give you the acceleration and the first derivative will give you the velocity. So basing on this concept, let us solve a question. Suppose the position and time relation is given here, like x is equal to 2t square plus 5t plus 1. The question is, find out the acceleration of the particle at t is equal to 10 seconds and the velocity of the particle at the same time. So at t is equal to 10 seconds, here x is in meter, time is in second. So t is equal to 10 seconds, find v and a. So at 10 seconds means instantaneous, already I have told you. If at a particular time it is asked, then that is your instantaneous value. The formula for v is dx by dt and a is dv by dt, the formula, as we are interested to calculate the instantaneous value. Now you find out the derivative of x, so which is d by dt 2t square plus 5t plus 1, which implies v is equal to d by dt of 2t square plus d by dt of 5t plus d by dt of 1. So you can take constant 2 outside, d by dt of t square, you take 5 outside here, so d by dt of t plus derivative of any constant is 0. Now just apply the formula, here it is 2, derivative of t square, here the power of t is 2, the formula is 2t power 2 minus 1 plus 5, here dt upon dt is 1, so derivative here it is means dt by dt is 1, so which is 5, and you are getting your, which implies v is equal to the 2 into 2 4t plus 5. This is the function of your velocity, means with the time the velocity changes according to this relation. Now your acceleration is dv by dt, means again find the derivative of this quantity or this function, so which is d by dt of 4t plus 5 to get the value of acceleration, which is equal to d by dt of 4t plus d by dt of 5, which is equal to, you can take the 4 outside, dt by dt plus t by dt of 5, it is again derivative of a constant is 0, so which means dt by dt is 1, which is equal to 4, which implies a is equal to simply 4. Got? So from here we can find the unit of acceleration is dv by dt, means it is meter per second divided by second, so the unit of acceleration is meter per second square. Now see, what it is asked? At t is equal to 10 seconds, what is the value of v and what is the value of a? All of you just see, while finding the function or finding the acceleration we got, it is only a number. Means the value of acceleration, it is a constant because there is no time term like this. In acceleration there is no t term. It means acceleration is independent of time. It won't depend upon the time. Means it is a constant term. Means at t is equal to 10 seconds, the value of acceleration is your 4 meter per second square. But the value of velocity, as velocity depends upon time, so you can put the value of t to be your 10 seconds because at 10 seconds it is asked. So you put t is equal to 10, so which implies 4 into 10 plus 5. So 40 plus 5 means 45 meter per second. So at t is equal to 10 seconds, the velocity is 45 meter per second. The velocity is 45 meter per second and the acceleration is 4 meter per second square. Thank you.